I also want to point out that the calendar, remember that here we had what we're doing yesterday, here's what we're doing today, and then this means we're going to have an assignment that should pretty much have the same name, at least it's the same color. It'll be real obvious what it is, but when it's due. So remember, anytime you ask me, Miss, when's this due? My answer is always going to be, what did you write on your calendar, right? And if you didn't write it down, you go on Schoology and you can see where it is, and everything's good, okay? All right, so today we're going to look at evaluating functions, and this is going on 26 when we're done. So we're going to talk about explicit equations and implicit equations. Does that sound familiar to you? Yes. Good. The answer is really probably no for most of you. So the rest of you are like, I don't really remember that. It's fine. The words I'm sure you've heard in your lifetime at some point, but I don't know that the words were used with you with the equations. You know what they are and you have done this. I just don't think the vocabulary was there with it. But for explicit, what does the word explicit mean? What'd you say? Nasty. Okay, I don't think it really means nasty, but somebody did bring that up, like explicit lyrics on. That's a different definition of the word, but yeah, I hadn't thought about it that way. What were you saying?
Like explicit, but it's like obviously.
Okay, yes, so it's kind of like obvious, or if I give you explicit instructions, that means they're very specific and stated very clearly, right? And then, yeah, then you have explicit lyrics. So it must have a second definition that I'm not that familiar with. I didn't even think about that one until somebody else said something. But so explicit in this case, we're referring to the definition of being stated clearly. So explicit equations are just equations solved for a specific variable. Okay, so it's when they're solved for a specific variable. So for instance, y equals 2x minus 5 and y equals the cube root of x minus 3. Just examples. So those are both solved for y, so those are explicit equations. Implicit equations is just the opposite of that. So these are equations not solved for a specific variable. So these examples, x squared plus y squared equals 7, and y minus 3x squared equals 4, something like that. All right, easy enough? All right, so we're going to look at these. We're going to do these first 6 examples 100% together. And these directions say to write each equation explicitly in terms of y. So you've kind of had those directions before too, because you have been told to write this in terms of y or in terms of x and be able to do that. So this says explicitly, which means we're solving for y, and then we're going to indicate whether or not it is a function. For some of these, when you look at them in the form that they're in, you should already have an idea of what the basic shape of the graph is and whether or not it's a function. For some of them, you won't, but then once you solve it for y, it'll be more obvious. So, and some of them, it's both forms that you would just totally know. Like for number 1, when I graph that, what is that going to graph? That's a linear function, right? Because you don't have any exponents on x or y. So you already know that it's a linear function, and it is a function. But we're still going to solve for y, because that's the first part of that anyway. So I'm going to do 2 things at once here and get x minus 20 equals 4y. Is that explicitly solved for y? Yes or no? No, because I have a 4 over there, right? So I divide by 4, so I'm going to get 1/4 x minus 5 equals y. And that still looks like a linear to me, right? So it is a function. It's that, and then the second part of the answer is yes. 2 parts to that answer. All right, number 2. What is that an equation of? Circle. Thank you. Who said that? Oh, Carly, my favorite student. It's a circle. And the rest of you looking at it like you have no idea. You learned those in geometry. It's a circle, right? So it is a circle. Is a circle a function? No. Okay, so I already know that the answer is no, but I still have to solve it for y. So y squared equals 25 minus x squared. Then what do I need to do? Square root. So y equals the square root of 25 minus x squared. Does that become 5 minus x? No. The answer is no. No, 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 no. Does not become 5 minus x. But is this 100% right? What's wrong with this? Plus or minus, who said that? There you go. Okay. Plus or minus. That took a really long time in some classes. Plus or minus. Right? You cannot forget that. When you take the square root, you get two answers. If I just left that as the square root of 25 minus x squared and there was no plus or minus, that would only give me the top half of the circle, and that is a function. But to get the bottom half, I got to have the negative. So please, please, please don't forget when you take square roots, you got to have the plus or minus. And then that way we know now, we already knew though, the answer is no. All right, so number 3. What's that going to look like when it's graphed? That is something you should have a good concept. Maybe not exactly. I know there's transformations and stuff, but like, what's going on here? What would it look like? How could you describe it? So if you think about it kind of in terms of like a parent function, meaning don't worry about the transformations and stuff yet, you have a y squared and an x that's not, right? So what if we had an x squared and a y that's not? What is that? Yeah, it's a quadratic. So y equals x squared, right? That's not what this is, but y equals x squared, the parent function looks like this, right? Right? It's a quadratic. It's a parabola. So what if x equals y squared? What does that look like? What does that look like as a graph? How are these, so just looking at this, what do you talk about this, how these are related? They're what? They're inverses of each other, right? And when they're inverses, the graphs are a reflection in which line? Y equals x. So this y equals x line is where it gets reflected, right? So when I reflect that down here, it looks like this. Now that's not exactly what this graph looks like because there's some transformations there, but we do know it's a parabola that's laying down, right? And since it's a parabola that's laying down and I shift it around, it's still, is it a function? So the answer is no. Okay, it's not. We know it's not a function. Still got to solve for y, but it's not a function. Okay, the concepts of what the parent functions look like, all that stuff's from Algebra 2. Those are things you should already know and be familiar with. All right, so I'm going to solve for y. I'm going to move my x over, so I'm going to get y plus 1 squared equals x plus 3. Then what do I have to do? Square root. So y plus 1 equals plus or minus, oh shoot, I gave it away. I was going to say what, but you have to have a plus or minus there, right? Dang it, I got ahead of myself and I wanted y'all to tell me. Square root of x plus 3. Then I got to move the 1 over, and y equals plus or minus square root of x plus 3 minus 1. And we decided before we started that it's not a function, which is probably a good idea because I think you even have less of a comfortable feeling about it right now. But we do know that the answer is no, not a function. All right, so what about number 4? When you look at it right now, do you just know what it is? My guess is probably not. I mean, maybe, and maybe if you kind of think about what's going to happen, but probably you're looking at that and you're like, yeah, I have no clue what the graph's going to be. That's okay. Let's solve for y and see if maybe it looks a little bit better. So 1/2 x minus 7 equals the cube root of y. Trying to get y by itself, so what do? Cube both sides, so I'm going to get 1/2 x minus 7 cubed equals y. Did you graph cubics in Algebra 2? Yes, you did. So you should have an idea of what that looks like. Is it a function? Yes. The parent function of a cubic looks like this. Okay. So this is a yes. Okay. We good? All right. So let's look at number 5. What about that one? When you look at that one right now, are you just like, yeah, I know what that graph kind of looks like? probably not. It's okay too. So let's solve for y. Let me get x minus 8 equals the square root of y plus 1. What do I need to do here? Square both sides. So x minus 8 squared equals y plus 1. And I got to move the 1. So x minus 8 squared minus 1 equals y. So what is that when I graph it? It's a quadratic. It's a parabola, right? Because that's your y equals x squared, right, with some transformations in there. So all we care about right now is that just, yes, it's a function. Good deal. All right, so when we look at 6, do you know what that is when you look at it? Probably not, right? A lot of blank stares tells me probably not. That's fine. I wouldn't expect you necessarily to without some deeper understanding. So we're going to solve for y. Well, I got 2 terms that have y in it. So I'm going to leave those here. And I'm going to move my 1 over. Remember, my goal is to get y by itself. So what am I going to need to do before I can do that? Factor it out. Good. So I'm going to factor out what? Y. So I'm going to get y times x minus 5 equals 2x plus. To get y by itself, what do I do? Divide. Good. So y is equal to 2x plus 1 divided by x minus 5. So this should look familiar. It's been quite a while on these, I believe, in Algebra 2. What is this called? It's a rational, right? And it's called a rational because it's written as a ratio, right? Rational ratio, right? Different forms of the same word. And ratios in math most of the time are going to be what for us? Fractions, right? So this is written as a ratio, so it is a rational. You graph these, you spend lots of time on them. Is this a function? Yes, because they were called rational functions, if that helps you at all. So even if that's the only way you knew, like you know it's a rational and you remember doing rational functions, well, there you go. So that x minus 5 in the denominator means that what's happening at 5? Right, that can't be a value. So on the graph, what do you draw at x equals 5? Asymptote. For the rationals, it's an asymptote at x equals 5. And then, you know, it splits apart. Okay, so then either way, right now, that's just a yes. All righty. So everybody okay with all that so far? Okay, so then function notation. Now this is probably didn't even need to be in here because if this is brand new to you, I'm really going to be worried. But this says explicit functions, not equations. Those were all explicit equations because we were deciding whether or not they were functions. But explicit functions are frequently written using function notation. So if I have y equals 3x squared plus 7, and I want that in function notation, what's the only thing that changes? The y, and it becomes what? F of x. So this is just f of x equals 3x squared plus 7. So then it says this is read as f of x. And again, if that's brand new, then I'm really worried because that's something that you've known forever. So then we're going to evaluate some of these. We're actually going to skip 7 and 8 because they're super easy, and I want to look at some of the other ones that where some other things happen on the back and just not run out of time. So let's start with number 9 on the back. All right. So as most of you know, and maybe all of you, because I don't know how if those of you that I don't know, if maybe you were in a pre-AP Algebra 2 last year or something, but at the pre-cal level, remember, it doesn't matter if it's pre-AP or on level, but for pre-cal, and you're on the AP track because we still are preparing you for calculus, even if you're an on-level pre-cal. But if you're on the AP track before that, one of the things that should be focused on with you quite heavily is correct notation, correct showing, not just showing work, but the correct way to show work and to show your process. Because the process is always way more important than the answer. Remember, if you can just look at this and substitute in that 4 and know the answer because you're like some kind of evil genius, then good for you, nobody cares, right? You're still going to just get it wrong. So the process is important, and how you do that process is important. I'm not saying you always have to show every single step, but there are important steps that you have to show. And you can be stubborn. You're just not going to get full credit, and I would hate for you to not get all the credit you deserve on an AP exam because you're just stubborn and refuse to write stuff down, right? So what you should do, plus, is this really a hard problem to substitute in for? No. Like, I know that you're capable of substituting that in and getting the right answer. Do sometimes you mess these things up? Yes, because we're human. Just don't lie. You know you do. I mean, nobody's perfect, and it's all fine. But also, when you actually do these things, the people that make the fewest careless errors are the people that actually do most of this stuff anyway without being told. But it will help you minimize some of that stuff and help you to get full credit on stuff. So when we substitute this in, this is what it should look like. P of 4. So I'm going to do P of 4 equals, in first step, 0 work. All you're doing is substituting it in. So we're going to do plus 1 over 2 times 4 squared plus 4 times 4 minus 13. Even though I know you know what 4 plus 1 is, at least I hope so, I'm still not writing 5 on the first step. You're substituting it in, because honestly, that's where a lot of the careless mistakes happen, because you're zipping through it because it is easy. You substituted it in, and now if you skip any steps, whatever, that's fine. But you have this, and then you just go from there. So in the numerator, that becomes 5. Then 4 squared is 16, times 2 is 32, and 4 times 4 is 16, and then minus 13. Then 16 minus 13 is 3, plus 32 is 35. Reduce to 1/7, okay? Now, I don't just box 1/7 and move on, right? I have to label my answer. That's equal to P of 4. Or if you want to rewrite it and rewrite P of 4 equals 1/7, that's fine too. But it doesn't matter if it's before or after, and that's a little less writing. So process is important. Somebody being able to follow what you were doing. Having equal signs in between this. Otherwise, what you're writing doesn't make any sense. So you have to keep that in mind. And remember, when I'm nitpicky about this, it has nothing to do with my feelings about it. And it's not because I'm a stickler about it. Well, I am a stickler about it, but not just because I feel like it should happen. My opinion doesn't matter. Your opinion doesn't matter. It's just we're trying to get you to get the most credit and do everything like you're supposed to. All right, let's do this one. G of 2. So it's going to give me negative 2 cubed plus 3 times negative 2 squared plus 7 times negative 2 minus 1. When you cube a negative number, what are you going to get? Negative number. Have that thought before you go do anything else so you don't mess that up, because the signs are what's going to kill you on a problem like this. And then what's 2 cubed? 8. So it'll be negative 8, and then negative 2 squared is 4 times 3 is 12, and then minus 14 and minus 4. All right, so negative 8 and positive 4. Well, that positive 4 and negative 4 cancel each other out. So G of negative 2 is just negative 14. It's actually safer doing it that way than on the calculator, because you mess up on the signs more on the calculator than anything else. And most of the time instead of doing it by hand. So we're good? Easy enough? All right, so let's look at 11. I want the Q of negative 15 equals the square root of 6 minus 2 times the negative 15. What is negative 2 times negative 15? Positive 30. So this is 6 plus 30. What's 6 plus 30? 36. Square root of that is 6. So Q of negative 15 equals 6. And it's not plus or minus 6. When you introduce the square root, you have to make sure that you have the plus or minus when you're solving equations. If it's already there and the intention was for you to get a plus or minus, it would be in front of that, like when we write it. Okay, so there's that one. You also have to, so you have to be very careful not to be sloppy with things too. When you're writing this square root sign needs to be there every time. You can't just like have whatever's underneath it because you're trying to simplify it and be lazy and not have that there. Otherwise, your process doesn't follow and it doesn't make any sense. Same thing here. These absolute value signs have to stay there. So this is the absolute value of 1/2 times a negative 10 minus 14. So I at least got to get it plugged in right and make sure I carry that stuff along. Absolute value. All right, so half of negative 10 is negative 5. And then minus 14, you get negative 19. What's the absolute value of negative 19? 15, and that's equal to the q, oh, not the q, that's a p of negative 10. Okay, everybody good? All right, so you do number 13. Actually do 13 and 14, and then stop for me. All right, so let's talk about 13. I would have f of 4 equals 5 times negative 3 to the 4th, right? So this is one of the ones where some of you are like, start really belly aching about not having a calculator, but totally not necessary. If you take a negative number to an even power, is it going to be negative or positive? Positive. Have that thought before you do anything. That now the sign doesn't matter at all, right? And then I'm going to take negative 3 to the 4th. So there was a lot of different kind of little scratch work things that were happening. And again, whatever works for you is fine, but I want you to learn to make your life a little bit easier and not always have crazy work all over the place, which is not as bad as I've seen in the past. But one thing I saw earlier that I just thought was good, and I'm not saying you should have to do it, you don't necessarily all need to do it, but it worked for this guy, and it was kind of a little bit different than what I would have done. He had this written out, and he had this, so I think that he did that to make sure that he used enough 3s, but not too many of them. You know, when you start doing that, like, how many have I done? And he kind of went down the line, and I think was doing some of it in his head. But 3 times 3 is what? 9 times 3 is 27. But then when we get to 27 times 3, not everybody can do that in their head that quick, right? And that's fine. If you can, great. If you can't, that's fine. I'm not saying you have to do it in your head. But learn different ways besides always writing it down and carrying and whatever. Because if I'm going to do 3 times 27, what's 3? Oh, that's 3. That's 20. If I'm going to do 3 times 27, what's 3 times 20? 60. And 3 times 7 is 21. And 60 and 21 is 81. See how that was not so bad? And again, I'm not saying you have to do it in your head. When you do 3 times 20, you might want to write the 60 down. And 3 times 7, you might want to write the 21 down. I have to do that sometimes or I'll forget what the first number was, right? When it's not hard, I don't even remember what I thought about. So that gives me that 81 without doing any like crazy big multiplication. So I'm going to get 5 times 81. Well, then when I get there, what's 5 times 80? 400, and 5 times 1 is 5, so this is just 4 or 5, right? And if you have different ways of reasoning through it, that's fine. I'm not saying you have to do it my way, but for those of you that don't have any way, start to try and think in terms of that, or think in terms of money. A lot of times that helps, so it doesn't just seem like overwhelming arithmetic that you have to do in the mornings. All right, and then on 14, I'm going to do a of 17. It's equal to the negative cube root of 2 times 17 minus 7 plus 1. So negative cube root. What's 2 times 17? 34. So 34 minus 7, and then plus 1. 34 minus 7? 27. Thankfully, right? Because you know what the cube root of that is. Plus 1. So what's the cube root of 27? 3. But then it's a negative out in front of there, so it's negative 3 plus 1. So you get your negative 2, which is a of 17. Questions on either one of those? We're good? Okay, stop me if you got a question. And if you messed up along the way, that's fine. Just find your mistake and make sure you understand why it's not whatever you did. Let's do 15 together. So f of 3y squared is equal to 3y squared cubed plus 3y squared squared. So what's 3 cubed? 27. You should know that pretty easily by now, right? Because here we did 3 times 3 times 3 to get that. There we took the cube root of it. So now when we get here, that should hopefully come to you pretty easily. So 3 cubed is 27. When you take a power to a power, what do you do with them? Multiply. Power to a power is multiply. When you're just multiplying, that's when you add. So it's going to be 2 times 3, which is 6. So y to the 6th plus 3 squared is 9 is y to the 4th, which in that case you would get lucky whether you added or multiplied, right? And then that's equal to the f of 3y squared. Okay, are we good? All right, I'll take that as a yes. Do 16 on your own. Okay, so did we all get at least to this point? We're good? Now, We can simplify. Be very careful when you're simplifying here. If you just start marking things out, things may not always end up too well for you. What do I need to do before I simplify? Factor. Good. Factor out the GCF. So in the numerator, the GCF is -5. So that's going to leave me with 3c plus 2. And then in the denominator, we get -5, and then that leaves me with c minus 1. Okay. Now you can just reduce by 5, or -5. That works if everything reduces by that, but that sometimes leads you to do some weird things, especially when you're left with a 1 down there. So officially, the correct process is to factor out the GCF. So then those cancel out, and that's when you're left with 3c plus 2 over c minus 1, and that is g of -5c. Very good. Any questions? Okay. All right, let's do 17 together. So this is going to give me h of 2a plus 7. So that's going to be 2a plus 7 squared minus 2a plus 7 minus 1. So what do you think about what I wrote down? Did I write all that down right? Nope, something's wrong. What am I missing? Parentheses. They're important here, right? They were important here because I was going to square it. Well, they're important here because this is negative. If this was a plus sign, it wouldn't be that big of a deal that I left them off. But if you're substituting in something with more than one term, always substitute it in with the parentheses. That way, if they matter, you're good, and if not, you're fine too. When you go to square this, you should be able to use the shortcut and square it like that. You shouldn't have to go off to the side and actually FOIL and do all that stuff. This should give you 4a squared plus what? 28a, and my pen's being weird, there you go. 28a plus 49. Then I get minus 2a, then what? Minus 7, good, minus 1. Now, if the shortcut to square that is something that you feel like you're a little rusty on, or any of this, we're not knocking the cobwebs off quick enough, Khan Academy is a beautiful, powerful place to go because it gives you very good little practice problems, and if you are struggling with it, there's a little video that goes with it right there. They can show you some examples. The videos aren't long and horribly boring. They're very well done. There's a lot of junk out there if you just Google it or try and find it on YouTube. Some of it's good, some of it's not, but Khan Academy is very good and can help you with those basic skills if you need them. All right, so then this gives me 4a squared plus 26a plus 41, and that's equal to h of 2a plus 7. Okay, everybody okay with that? All right, I'll take that as a yes too. All right, so I'm going to give you some time. I want you to work on 18 on your own. Now, I'm not sure if I mentioned to you, but this blank space over here, if you need it for extra scratch work or whatever, it's there, so you don't have to cram things. If you're still working along, you can work along and ignore me, or I'm going to kind of talk you through how I did this, which you don't always have to do it in the exact same order or the exact same way that I do it, but 4 times m minus 1 cubed plus 7. Well, first of all, can I distribute the 4 before I do anything? No. Aunt Sally says no, right? We have to listen to her with our order of operations. So that 4 has to stay out there. So I'm going to cube it. I'll start by just squaring it. So I'm going to leave this 4 here. If I just square that, that's going to give me m squared minus 2m plus 1. Then I still have another m minus 1 I would have to multiply in there, right? So then the next thing I'm going to do is take this m and distribute it into there. So this is going to give me 4 times m cubed minus 2m squared plus m. Then I'm going to distribute that -1. So minus m squared plus 2m minus 1, and then plus 7. So then next, I'm going to combine my like terms and multiply and distribute that 4 at the same time, just so I can save some steps here. So I only have 1 of the m cubed. So this is going to be 4m cubed. I have -2m squared and negative, so that's going to be a -3m squared times 4, -12m squared, -2m, and, oh wait, ooh, I did something wrong somewhere, didn't I? Where did I mess up? Dang it. I didn't mess up. Well, these shouldn't cancel out. Oh, that's 2m squared. I'm sorry. I couldn't read my own handwriting. That's my problem. All right, so good. I didn't mess up. Whew, I just can't read. So m and 2m, that's 3m times 4 is 12m. And then 4 times a negative 1 is a negative 4 plus 7 is 3. And that is k of m minus 1. We good? Algebra's fun, isn't it? Yes, it's like little puzzles. It's exciting when you get it done. You know y'all are having fun, whether you think you are or not. All right, the last part says, using the graph to the left, find each function value. So when it asks you to find the function value, what is it asking for? The y value. It's not asking for an ordered pair or anything else. The function value is the y that it's asking for. So if I'm looking for f of 1, well, f of x is your y, so your x is 1. So when x is 1, what is y? That's all it's asking you for. So when x is 1, what is y? Negative 9. Y'all agree with that? Is that easy enough? All right. So while I pass out the homework, you do these last 3, and then I need to make sure that I tell you something about the homework. All right. So for 20, this f of negative 2, what'd you get? 0. F of 5, what'd we get? 6. F of 0, get? Negative 8. Look, little geniuses. Great. All right, any questions on that? All right, grab the homework. Let's look at that real quick. So here, where the directions start right before number 4, it says, give the domain and range of graphs 4, 5, and 6 in set notation, and 7, 8, and 9 in interval notation. Mark out set notation. You're doing it all in interval. Okay, so all of them, 4 through 9. No set notation, all in interval. Okay, we good? Questions? All right, so got a few minutes left.